In this video I'm gonna talk about repacking an APK. Maybe you have a sensitive question before I start. Why do someone back an APK like that? In the fact, most developers do that to protect their apps from being reversed by reverse engineers, and sometimes this is done because of another purpose. Some malware developers do that to bypass the security systems inside Android or other operation system, because the original code is hidden and loaded inside the runtime only, and this can trick the security systems and antivirus to do their job. I have a demonstration application here, and thanks for my friend Adrian, because he made this app and bagged it. The application is just for Hello World, a very simple app, and thanks for my friend Sion for his script. As we start with opening the APK file on Jadx. It's always preferred to start by looking at Android manifest.xml, but I wanted to check files too. Here in the sources you will find the APK files. The assets file has some of .so files. These files can be familiar for some of you because there is a famous protection is using it, but here is not a real protection. It's not that protection from the Chinese company. And here in the lib folder you find RMB and x64, and again some .so files that can be used in that protection. Meta file is for original signature. Resources are for XML files and pictures and whatever inside the APK. Android manifest.xml will be our start. It can show a lot of information about the application, like package name and SDK version. You can see here version 2.2, the package name here. I will copy that because we will need to use Frida. Large applications you can find more information like permissions and more activities like here. This tag is representing the default class which the app starts from this entry, which is Android name, to this class. This class have name stub app, or stub is a normal name for most protections, and some malwares used to. So let's start from it. We have here the main activity too, but it's not included inside the classes here because it's loaded later when this class here does its job. Sure, these classes here are helping this class to do its job. Here I'm putting the needed modules for the Android app. As you see here, android.app.application, it's for the default class in the application, so this class considered to be the default class. At the start here, you will find a private static SO name, which mentions that the SO file that we find in a seeds folder, and another private static string, which is extracted Dex file name, which is the same name but the Java file. Here it's doing some operations. We can find the results of this. The two results of this private string is in create function inside the same class stub app. Here is it. Here is the loading the class from that file here, which is extracted Dex file name. In configuration class, we can find that it's doing some job waiting with the stub app class. Here is a string classes.dex, which is the original classes file. This condition and this loop is trying to get this class from an archive, which is this archive. So we can understand this is not a real Java file, it's just an archive with the name .java. Here is reading it. Here in this try and catch, we can notice that this Java file was mentioned too. I return it back to stop. As you see here, there are a lot of native methods which should be in the lib. Now here, when these two classes do the job cooperating with each other, it uses this built-in function which is delete to delete this file. Like any protection, this protection is loading the original file in some place in memory that the user can't access, and when the application runs, it deletes it to not be found.